So now let's see what a reference angle can actually do for us when we're talking about our trig. Here I have drawn for you a circle, which we call the unit circle, and I'm only going to focus, however, on the first quadrant here. So let me just highlight this here. In the first quadrant, you can see that I know I go from 0 to 90. So any angle measurements in the first quadrant would be acute angles. For this first special angle that we have here, remember we talked about three special triangles. We have the 30, 60, well, two triangles, the 30, 60, 90, and the 45. So for this first measurement here, this would be 30 degrees. This second measurement here would be 45, and the third measurement here would be 60. If I know the six trig functions for 0, 30, 45, 60, and 90, then I can fill in all the remaining quadrants from here, because these values are just going to be, they're just going to repeat. Take, for example, the 30 degrees that I have here. If I know that this little slice of the pie is 30 degrees, then that is the same as this little slice of the pie over here. In other words, my six trig functions for 30 degrees on the first quadrant are similar to my six trig functions for this little slice of the pie in the second quadrant. So to get this value, to find out what this is over here, if I wanted to know what this measurement was, I can go all the way across to 180 and subtract off 30, and I am really sitting at 150 degrees. In other words, my unit circle is symmetric and reflexive. So all the values over here for 30 apply to these values over here in the second quadrant. They also apply to these values down here in the third quadrant, which I could get by saying 180 plus 30, okay, which gives me, what, 240? 210, excuse me, can't add, 210. And then I also know that I would also have values over here in the fourth quadrant, and that would be 360, because if I go all the way around the circle and then back up, minus 30, that gives me 330. 330. So if we focus on learning the values for the first quadrant, I can then fill in values for all the remaining quadrants around the unit circle, and that's a very, very powerful tool for us, and it reduces the amount of memorization that we have to have. So let's kind of apply that in this example. So this example says I want to find the six trig values for 225 degrees. Let's back up 1 second and let's recall our three triangles and how they laid out. We had our 30-degree triangle. Okay, if you remember that if I'm talking about a 30-degree triangle, then my short leg is a 1, my long leg is the square root of 3, and the hypotenuse is 2. If I have a 45-degree triangle, both my legs are the same. Okay, so this is 45, and the hypotenuse is the square root of 2. If I have a 60-degree triangle, my short leg again is 1. The long leg is the square root of 3. This is for 60 degrees. And the hypotenuse is 2. Okay, that's how you know how this breaks down. Short leg for 30, 60, 90. Short leg is always 1. Long leg is always square root of 3. Hypotenuse is always 2. So if these are my three choices that I have here, and I want to find out, my question is asking me to find out what the six trig functions are for 225, we're going to use reference angles. And reference angles is going to give us one of these three triangles right here to find out what the trig functions are. So start by making a picture. Okay, 225. 225 travels past 180 and stops somewhere down here in the third quadrant. So we could say 100, not 180, we could say 225, because I'm going to travel 225 degrees, minus 180, and 225 minus 180 is going to be 45. So in other words, this small amount right here is a 45-degree triangle. Well, I know, because you're memorizing them, what the 6 trig functions are for a 45-degree triangle. And then because I know that really I'm looking for the trig functions for 225, which ends right here in the third quadrant, I know 2 of the trig functions, cotangent and tangent, will be positive down here, and the remaining 4 trig functions will be negative. Okay, so sine, if I'm looking at the sine of 225, then I know sine is going to be y over r. Y would be the vertical direction, r is the hypotenuse, so it would be 1 over the square root of 2, which is going to be the square root of 2 over 2. But sine is negative down here in the quadrant, in the second quadrant, or third quadrant, excuse me, so we put a negative on. Let's look at the cosine of 225. Cosine would be x over r, which again is negative square root of 2 over 2, because cosine is negative in the third quadrant. Okay, how about tangent? Tangent of 225 would be y over x, which is just 1. And then we can come over here and we can do cosecant of 225. Cosecant of 225 would be the reciprocal of sine, so that's just going to be the square root of 2. And again, it is negative. Secant of 225 is the reciprocal of cosine, which is negative square root of 2. And cotangent, which is the reciprocal of tangent, which is 1. So by using reference angles and only really having to know the first quadrant right here, I can figure out what all 6 trig functions are of 225, which is occurring down here in the third quadrant. So this next example we're going to look at asks us to find the exact value of the sine of negative 150. So we're going to let reference angles help us do this, but we're first going to start by drawing a picture. So if I have the sine of negative 150, remember the negative value means that I'm going to move in a clockwise motion, so I'm going to move all the way over here, not going quite 180, stopping here in the third quadrant. So I'm going to find out what is the reference angle for this small value right here. Okay, and to do that, I know that that's 180 minus 150, giving me 30. So I'm going to let the sine of 30 tell me what the sine of negative 150 is. So we're going to use that as a reference angle. The sine of 30, remember that if I have a 30-degree angle, then I have 1, the square root of 3, and 2. And sine is always going to be y over r, so that would be 1/2. But I'm really looking for the sine of negative 150, which is occurring down here, so that would be negative 1/2. One more time, let's try that using the cotangent of 780. Reference angles are going to help us find that. Okay, so 780, how am I going to get 780? So drawing a picture, I know that if I go one time around, that's 360. If I go another time around, that's 720. And I know I'm going to end up somewhere here in the first quadrant. So I have 780, because that's my angle measurement, minus the 2 revolutions that I know about. and that's going to give me 60 degrees. So I am going to find out what the cotangent of 780 is based on the reference angle of 60. So if I have a 60 degree angle, that means that I'm going to have 1, the square root of 3, and 2 in this shape. And I know that cotangent then of 780 is x over y. So I have x over y, which is 1 over the square root of 3. Rationalizing the denominator gives me the square root of 3 over 3. Since my angle ended here in the first quadrant, I know that this value is positive. Using this theme of reference angles, let's see if we can then evaluate this expression right here. In other words, if I'm going to evaluate it, I need to give me some sort of numerical value back, typically. So I'm looking at the sine of 45. I'm going to have to figure out what the sine of 45 is, the cosine of 135, and the tangent of 225 is, before I can really do anything. So the sine of 45 is going to be a positive value, and I know that if I have a 45 degree triangle, then I have something that looks like 1, 1, and the square root of 2. So the sine of 45 is y over r, which is 1 over the square root of 2, or the square root of 2 over 2 when I simplify it. Cosine of 135. Okay, cosine of 135. 135 is not acute, so we know that if I'm talking 135, I'm somewhere over here in the second quadrant. So I'm going to say 180 minus the 135, and I find out that that in fact is 45. So I'm still looking at a 45 degree triangle, only this time I want to know what the cosine of that is. So the cosine of 135 is going to be x over r, which is 1 over the square root of 2, or the square root of 2 over 2. But because I'm here in the second quadrant and cosine is negative in the second quadrant, this value should be negative. Now the last one I'm looking for is the tangent of 225. So 225 is past 180 down somewhere in the third quadrant here. So I'm going to take 225 minus 180. I find out that that's also 45. So I'm looking for this little acute angle here. So the tangent of 225 is y over x, which is just 1. And tangent is positive down here in the third quadrant. So what did I find so far? I found the components, these three values here, that I can then substitute into this expression and simplify. So what this is going to look like looks something like this. If I talk about sine of 45, this actually says sine squared of 45. So I'm going to take the square root of 2 over 2, which is the sine of 45, and I square it, plus 3 times cosine squared of 135. Well, the cosine of 135 is negative square roots of 2 over 2 squared, minus 2 times the tangent of 225, which is just 1. So this green expression right here is what we are now going to simplify. So the square root of 2 over 2 squared means I square both the numerator and the denominator, giving me 2/4 plus 3 times, again, 2/4 minus 2. If you simplify this entire expression right here, then you'll see that you get 0. So this last example asks us to evaluate the function, but I want to be able to do it in terms of some numbers between 0 and 360. So it's similar to what we've been talking about already, but in other words, I'm really looking for a coterminal angle that's coterminal with 585 degrees, but it falls between 0 and 360. Okay, so if I go all the way around the circle one time, that's 360. This is more than that, but how much more? Well, if I take 585 minus the one revolution of 360, I'm really looking at some value which is 225 degrees. Okay, 225 then means that I'm going to go all the way around and end in this third quadrant. But we're going to use reference angles to be able to find out what the sine of 225 is. So 225 minus 180 ends up being 45 degrees. We've been practicing a lot with our 45 degrees, so if I'm looking at the sine of 45, which is y over r, then I know that that's the square root of 2 over 2. But remember, because I ended in the third quadrant over here, sine is negative. Okay? So that's really what this type of question is asking. A coterminal value for the sine of 585. Let's try that one more time using the cotangent of negative 930. We're going to start by making a picture. So if I were to draw this out, remember negative 930 moves in the clockwise rotation, so I would go 360. One more revolution gives me 720. Well, I'm not done yet, am I? So I say, okay, how many more degrees do I have to go? 930 minus 720 gives me 210. But this is 210 in the negative direction. Okay? If I moved 210 degrees in the negative direction, that puts me over here in the second quadrant. But I want my values to look like they're positive. So the way that I do that is, well, how much is it then going this direction? Because I'm trying to find out what that is. So I could say 360 minus the 210 is a positive 150. In other words, if I were to turn around and go in the positive direction, I go 150 degrees. If I go negative, I go negative 210. Back at the same point. Those would be coterminal. So what I'm really looking for is the cotangent of 150. But how does that relate to my reference angles? I'm really looking for that skinny little acute angle value right there, which is in terms of 180 minus 150, which is 30. So if I find the cotangent of 30, that's going to give me the cotangent of 150. So a 30-degree angle is a 1, square root of 3, and 2. Cotangent is x over y, which would be the square root of 3 over 1, or just the square root of 3. But because we're over here in the second quadrant, my value is actually negative. So let me rewrite this up here, that the cotangent of 150 is technically the negative square roots of 3. And there we found that.